Okay, so starting off with the bell ringer, the question was, how does a simple machine reduce the force needed to move an object? Who could answer that? Let's see, who's out there? Jaden, what do you think? How does a simple machine reduce the force needed? You want to take a shot at that, Jaden? Are you there, Jaden? Can you hear me? Jaden, are you available? Sean, are you there?
Hello?
Yeah, okay, Sean. So what do you think? How does a simple machine reduce the force needed? Does anybody remember that one? That's kind of a difficult question. I'll give you that. It's not an easy question. Devian, what do you think? How does a simple machine reduce the force needed?
What?
How does a simple machine reduce the force needed to move an object?
A simple machine reduces the force needed to move an object by increasing the distance.
Very good. Perfect. Yes. Okay, so the way a simple machine works is it increases the distance needed to move an object. By doing that, it decreases the force. For example, an inclined plane, which is a ramp, okay? What it does is it makes you move a greater distance. However, by doing that, it reduces the force, okay? With that being said, let's go ahead and look at our graphs. So today we're going to be drawing graphs. We're going to draw about 20 graphs. Do not draw these very big. You can draw them, fairly small. Don't be tiny or nothing, but maybe 3 or 4 lines high. Not nothing big. So we're going to be drawing about 20 graphs. This is actually kind of our last subject in physics, which is sad because it's what I like to teach, chemistry and physics. After this, we'll be moving on to Earth and space science, I believe. Actually, Earth science. We'll be looking at the Earth and rocks and things like that. But anyways, with that being said, everybody have their science notebook out, ready to go? Draw graph number 1. Here's graph number 1 right here. Oh, y'all can't see my screen yet, can you?
No, you're not screen.
All right, there we go. Okay, there's graph number 1. Everybody go ahead and draw graph number 1. All right, so let's talk about a few things. First thing, draw this graph. Distance and time. For the first one, write distance and time, but you only need to do that once, just for your notes. Everybody should be drawing this. Okay, distance is in meters, and time is in seconds. So go ahead and label that distance and time. Distance, technically in science, is always meters, and time in science is always technically seconds. However, because this is junior high science, and the people who write some of the stuff are not very technical, you will see all types of things like miles and hours and minutes, which we would never really use in physics class. Have you drawn this, Brianna? Have you drawn your graph? Okay, so everybody needs to be drawing and labeling these graphs. You will be using these. So Brianna, you don't have a science spiral? Okay, so with that being said, what can we say about this? Well, distance is always on the y-axis and time is always on the x-axis. If I had units on here, this right here would be 0 meters and 0 seconds. So first thing, is it moving towards 0 or away from 0?
Away from 0.
Yeah, it's moving away from 0, right? So in other words, what I could say is that it's moving away from the origin. So it's moving away from origin at a constant speed. Okay, how do I know? Well, it's a straight line. So in other words, if I was to divide distance divided by time anywhere on this line, I would always get the same speed. For example, let's say it's 4 and 2. So if I drew a line right here, and that line was 4 meters and 2 seconds. Well, 4 divided by 2 is 2. If I draw a line here, let's see, that's 8 meters and 4 seconds. What's 8 divided by 4? 2. Well, let's say right here is 10. Well, 10 meters and 5 seconds is 2. All right, I would always get the same answer. I would always get 2. Because it's a straight line, and that's a distance-time graph, it's always going to be 2. 2 meters per second. All right, let's look at graph number 2. Here's graph number 2. Well, let's compare. Go ahead and draw, everybody go ahead and draw graph number 2. Everybody draw graph number 2. Brianna, let's take our headphones out. I don't feel like I have your attention. Y'all should be drawing graph number 2. Come on, James. I should be seeing y'all draw right now. Draw graph number 2. You already drew graph number 2? Okay, everybody draw graph number 2. And let's do this. Let's add a line to it. So James, what could you tell me about line A? Let's call this car A and car B. What's the difference between car A and car B, James? Let me ask you this. Which one do you think is going faster? Do you think it's car A or car B? Yeah, car A, okay? Line A is meant to be this one right here, okay? Line B was the new graph. So what can I say? Well, car A is faster than car B. Okay, how do we know? Well, line A has a steeper line than line B. Okay, so car A is faster than car B. Why? It has a steeper line. Here's what I tell students. You get your pencil. Everybody get your pencil in your hand. This right here is 0. It's not moving. As you go like this, that's faster and faster and faster. And I'll actually show you all that here in a second. Okay? Everybody draw those 2 graphs and label them. Make sure you're labeling them. Car A is faster than car B. That's what we can say about that graph. Okay, number 2. Here's number 2. What's the difference between number 1 and number 2? So what do you think, Brianna? What can you tell me about this graph? I'm sorry? I did cut in half? No, let me ask you this. Is it going towards the origin or away from the origin? Okay, well this right here would be 5 meters. This right here is 0 meters. So is it going towards or away from the origin? It's going towards the origin. Very good. Okay, so yes, what we could say about this one, go ahead, everybody draw this graph. Remember, this is our distance, or meters. And what could I say about this? I could say that this is moving towards the origin at a constant speed. Okay, so it's moving toward the origin at a constant speed. Okay, number 3. Everybody got number 2, right? I'll give you a second. Which I guess I forgot to ask. Did y'all see any snow on yesterday? What was it yesterday? Sunday. Did y'all see any snow?
No.
No?
No, but I went to the Grand Canyon and there was snow there.
Did y'all see snow? A little bit of ice. Yeah, I've kind of heard, some students are saying yes, they saw snow. Some are saying no. You know, I live out in the hill country and we saw quite a bit of snow. None of it stuck to the ground, but we had some big snowflakes. It was kind of funny because it would snow and it would stop and then it would rain and then stop and then snow. It was kind of, it'd rain for a while and then stop and then snow for a while and then stop. My brother lives north of Austin and they got like 5 inches. They got a lot of snow. In fact, nobody went to school today. They're all doing virtual at home.
Where my dad works, the place, it was so snowy, like it stopped so much snow, and he only go to the work to with the snow.
Yep, so anyways, what was it, 2 years ago, we had a couple inches of snow, and guess what happened? I totaled my truck on the way to work. I told my wife, if it snows, I'm not going to work. And I woke up the next day, and there's a few inches of snow on the ground. This was, 2 years ago or so. And sure enough, I get about a mile away from my house. I get to the first bridge, and I rolled my truck on the highway. Actually totaled my truck. Just about killed me. This time, I told myself, if it snows, I'm not going to work. The funny thing is, nobody ever bought me a new truck, so I was going to risk another truck over that. All right, so towards the origin at constant speed. Number 3, everybody draw this graph. Everybody draw the next graph. All right, so here's what I tell students to do. It's kind of hard for me to do because I'm backwards. Everybody get their pencil. If this is not moving, okay, so if your pencil's flat, that's not moving. That would be slow, getting faster, getting faster, getting faster, getting faster. The steeper your pencil is, the faster you're traveling, okay? So slow, faster, 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 and faster. So if your pencil goes like that, you're speeding up. If your pencil goes like this, you're slowing down. So let's look at graph number 1. It's kind of hard for me to do because this is like a mirror where I'm doing things backwards. But what is this doing? Speeding up or slowing down? Watch my pencil. Does my pencil point up or does it go down?
Speeding up.
It goes down. Look at my pencil. See how right now it's pointing up? As I trace my graph, what happens to my pencil? It starts to go down. So what's happening? It's slowing down. So everybody write that. Draw this graph, and what's happening? It is slowing down. Actually, first thing we say, it's going away from the origin. The next thing we can say is it is slowing down. So it's going away from the origin, and it is slowing down. Okay, well, then what is this one doing? Yeah, this one's speeding up. Everybody take your pencil and trace it. And what happens? Your pencil starts to do what? Starts to point up. Okay? So, yep, as we trace it, your pencil begins to point upwards. So what is that one doing? It is going away from the origin again. It's going away. And it is speeding up. Why? Well, because if I trace it with my pencil starts to point up. Okay? It doesn't matter what direction. If it goes that way, that's speeding up. If it goes that way, that's speeding up. Okay? So if it starts to go, think about it like a hill. Okay? This hill would be very easy to walk up. That hill would be hard to walk up. That hill would be very hard to walk up. Okay? So the steeper the hill, the faster it's going. So in other words, what's going on? It is speeding up because it starts to point upwards. Next one, number 4. I'll give you all a second to continue drawing that. Actually, I think I missed somebody on attendance here. Give me a second. Annalise, are you here today? Annalise, I think, is absent. Is that correct? Annalise, are you here? She's absent today. Okay, next graph. Now, I couldn't find these graphs, so we're just going to have to draw them. So, everybody write this. We're going to draw a graph that's going towards the origin and speeding up. Now, these are the graphs that people get wrong because it doesn't quite look like what you think it would look like. So let's everybody draw a graph. This is my distance, which is meters. This is my time, which is seconds. Okay, graph looks like this. All right, everybody take your pencil and trace that. Is that speeding up or slowing down? Take your pencil and trace it. What does your pencil do? Does your pencil go down or point up?
It goes down.
Look at it. Trace it. Your pencil starts to point up. Do you see that? Everybody trace that line. If you trace that line, you notice your pencil will do that. And because that, it is speeding up. Oh, and I guess I gave you the answer right here, right? We're drawing a graph of something speeding up. So what would slowing down look like? Everybody draw the next graph. Label it slowing down. Here's what slowing down would look like. This is my meters. This is my seconds. What are you showing us, James?
Oh, I took one example from the one that showed us that it was kind of like a triangle, and then I made one that was slowly.
There we go. That's slowing down. So here is speeding up. Here is slowing down. Trace your pencil. Trace it with your pencil, and you'll notice your pencil does what? It lays down. Okay? So speeding up versus slowing down. Next one, number 5. What's going on here?
It's just going in the straight line with the pencil.
Okay. It's not moving, right? So in other words, it's not moving. If you trace your pencil, does your pencil go up or down? No, it stays just like that. What's happening here is it is not moving. Not only that, but I can tell you that not only is it not moving, I didn't mean to do that. What else I could tell you is that it is not moving and it's away from the origin. So in other words, what I could say here is I left home and I go stand at the street corner. Here I am. I'm not at home. I'm away from the origin, and I'm standing at the street corner. So big thing is what is it doing? It's not moving. So in other words, if it's at 5 meters, it stays at 5 meters. So how will we draw not moving at the origin? If I draw a line that looks like this, that's not moving at the origin. Okay? So go ahead and draw that one. Not moving at the origin versus not moving away from the origin. Both of them are not moving. It's just one of them is close to the origin. Just noticed that they're having kindergarten roundup. My kid's going to kindergarten next year. Hard to believe. Seems like he was just born a couple days ago. Okay, next one. Number 6. Let's go ahead and label this A, B, and C. So we have line A, we have line B, and we have line C. So what can we say about line A?
And so it's
It's going towards the origin or away from the origin?
towards the
Very
origin.
good. It's going towards. Not just that, but we could say at a constant speed because it's a straight line.
Yep.
What can we say about line B?
It is, I guess, not moving.
It's stopped moving. What can we say about line C?
It's going up.
It's going away.
It's going away. Okay. Not just that, but we could also say, look at A and C. What's faster, A or C?
A.
A, right? Brianna, I don't feel like I have your attention. Are you paying attention or are you doing something else? Okay. I kind of feel like you're off on some other website or something. All right, so what can we say about line A? Line A is fast. What can we say about line C? Line C is slow. Okay, so fast versus slow. Everybody needs to be drawing that. Again, you could use these later to answer questions. Everybody's drawing this, right? Okay, moving on. Number 7. Everybody draw number 7. You don't need to put all the numbers. However, what I do want you to put is right here. I would like you to label that with 50 meters. And then right here, that is, what's halfway between 20 and 30? 25. Okay. So, knowing that, can we calculate speed? The answer is yes, because speed is equal to what? Speed is equal to?
Divided by time.
Very good. Distance divided by time. Speed is equal to, what's my distance? 50.
50 meters.
What's my time? 25 seconds.
5
Yeah.
seconds.
Seconds.
What's 50 divided by 25?
2.
2.
0.5.
2 meters per second.
2 meters per second. That is what I want everybody to do. Okay? Draw this graph, ABC. I can describe the the motion for you. Point A is moving away from the origin. Point B is stopped. Point C is moving away from the origin at a faster speed. So I can tell you about point C. It's moving away at a faster speed. What is point B doing? It's not moving because it started off where? 50 meters. Ended up where? 50 meters. What's 50 minus 50? 0, right? So it moves 0 meters. In other words, it's sitting still. Everybody draw that? Okay, next one. Number 8. What is the speed of the runner between 0 and 4 seconds? All right, well, let's look at it. Here's 4 seconds. Everybody go ahead and draw this graph. You only need to label this 12 and 4. So, what's the motion here? It's moving away from the origin at a constant speed, and then it stops. So, let's calculate it. Speed is equal to?
Distance divided by time.
Thank you, Devion. Distance divided by time is equal to, what's my distance? 12. What's my time? 4. What's 12 divided by 4? 3 meters per second. Okay?